For as long as humans have feared the dark, we've wondered what might be hiding inside it. The night sky has always been our greatest mystery and our greatest inspiration. We painted myths onto the stars, we used them to navigate oceans and eventually to guide spacecraft beyond our world. But hidden among those billions of lights are regions of perfect darkness. Places where the universe itself seems to fold in on itself. Places where our deepest questions about time, space, and existence collide. These are black holes. A black hole begins its life not as a monster, but as a star so massive that when it burns through its fuel, no force in nature can stop its collapse. Its outer layers explode in a brilliant supernova, but its core falls inward, endlessly, until it becomes a singularity, a point of infinite density. This singularity is hidden by the event horizon, the ultimate boundary. Cross it, and escape is impossible. Not even light, the fastest thing in the universe, can make it out. But what would happen if we approached one? From a safe distance, our instruments would reveal bizarre effects. A spacecraft nearing the event horizon would appear to slow down. Its light would shift to deep red, stretched thin by the warping of space-time. To an outside observer, the ship would never cross the boundary. It would freeze, suspended forever at the edge of the abyss, a ghost on the doorstep of eternity. But for the pilot inside, the story is very different. Their clock ticks normally. They pass through the horizon without warning, without even noticing. To them, time flows as always. But the outside universe accelerates wildly. Stars age and die, galaxies collide, entire epochs flash by in moments. In a way, a black hole is a time machine. Not one that lets you travel back, but one that can fling you forward into the deep future. As the pilot falls closer to the singularity, gravity grows extreme. The pull on their feet is trillions of times stronger than on their head. Their body stretches, atom by atom, into a thin strand of matter. Scientists call this spaghettification. It's a poetic word for a silent and horrifying end. Yet even in death, there is beauty. Imagine looking outward just before the final moment. The universe outside would appear distorted, twisted into arcs of light, entire galaxies smeared across the sky like brushstrokes, a cosmic painting glimpsed only by those doomed to see it. Black holes are not rare monsters lurking in the dark. They are fundamental to the structure of the universe. At the center of almost every galaxy, including our own Milky Way, lies a supermassive black hole. These giants can be millions, even billions of times the mass of our sun. And, far from being silent, they can roar. As matter swirls into them, it heats up and releases radiation so intense it can outshine entire galaxies. Some of the brightest objects in the cosmos, quasars, are powered by supermassive black holes. In a strange way, without black holes, galaxies as we know them may never have formed. They are both destroyers and architects. For centuries, black holes were thought to be purely theoretical, but in recent years, we've begun to hear their voices. When two black holes collide, they send ripples through space-time itself, gravitational waves. We can now detect these faint echoes here on Earth, vibrations in reality that confirm Einstein's most daring predictions. And in 2019, humanity saw the unseeable. The Event Horizon Telescope captured the first image of a black hole shadow, a glowing ring of light bent and trapped by gravity. For the first time, we looked directly into the abyss. But even black holes may not last forever. Physicist Stephen Hawking proposed that they slowly evaporate, releasing faint radiation over unimaginable timescales. A black hole could take longer than the age of the universe to disappear. But eventually, even these cosmic giants might fade. What would the universe look like when the last black hole dies? In that far, far future, with no stars, no galaxies, no light, only silence may remain. And yet, black holes may not only be ends, they could be beginnings. Some scientists wonder, could a black hole be a gateway? Could what falls in emerge somewhere else, perhaps in another universe entirely? A wormhole connecting distant corners of reality? We don't know yet. Perhaps we never will. But that's the essence of science. Every answer leads to deeper questions. Black holes remind us of our limits. They're cosmic mirrors forcing us to confront how small we are against the vast, mysterious universe. But they also remind us of our potential. From Earth, a tiny blue dot, we can imagine, predict, and even observe these monsters billions of light years away. And maybe that's the true power of black holes. Not just the power to bend light or to devour stars, but the power to inspire us, to push us forward, to make us reach for understanding in the face of the unknown. In the end, black holes are not just cosmic abysses, they are questions carved into the fabric of space-time. Questions about beginnings, endings, and everything in between. And as long as we keep asking, as long as we keep looking into the dark, perhaps we will discover that the universe's greatest mysteries are not out there among the stars, but within us, in our endless desire to understand.